Hello, today we are going to use a Laplace transform to solve the second order differential equation. If we have a second order differential equation of y double dash plus 9y equal to 4 cosine t, where the initial condition is y0 equal 1 and y dash 0 equal minus 1. And today we are going to using Laplace transform to solve this equation. So first of all, we take the Laplace transform on both sides. We have the Laplace transform of y double dash plus 9 Laplace transform of y equal to 4 Laplace transform of cosine t. And the Laplace transform of y double dash is equal to the s squared function of s minus s y0 and minus y dash 0. So this term is coming down to this term. And the Laplace transform of y is equal to a function of s, and the 9 is in front of it. So this term is coming down to this term. And the Laplace transform of cosine t, from the Laplace transform table, you can get s over s squared plus 1. Let's see the Laplace transform table. From the tables of number 8, we can see that the Laplace transform of cosine at is equal to s over s squared plus a squared. So if this is cosine of t is equal to s over s squared plus 1 squared. So s over s squared plus 1. Therefore, we get this term cosine t is equal to s over s squared plus 1 and multiplied by 4. And then we substitute the initial condition. y0 is 1, so it's minus s. And then y dash 0 is minus 1, so it's minus 1 is plus 1 equal to 9. Function of s equal to 4s over s squared plus 1. We simplify the equation into s squared plus 9, so similar terms together, and minus s plus 1 equal to 4s over s squared plus 1. And we take the minus s and plus 1 into the other sides, we got plus s and minus 1. And then we divide s squared plus 9 on both sides, we got the function of s equal to 4s over s squared plus 1, s squared plus 9, plus s over s squared plus 9, minus 1 over s squared plus 9. Then we take the inverse Laplace transform on both sides. On the left hand side, we got the inverse transform of this function s is equal to yt, of course. And on the left hand side, we got the inverse Laplace of 4s over s squared plus 1, s squared plus 9. And the inverse Laplace of s over s squared plus 9 minus 1 over s squared plus 9. And from the Laplace transform table, we can get this, the inverse Laplace of s over s squared plus 9 is equal to 1/1 of cosine 3t, and the inverse Laplace of 1 over s squared plus 9 is equal to 1/1 of sine 3t. From this table here, we can get the inverse Laplace to sine and the inverse Laplace to cosine. And then if we want to solve this inverse Laplace of 4s over s squared plus 1 s squared plus 9, we have to first doing the partial fraction of s over s squared plus 1 s squared plus 9. So this is equal to, after the partial fraction, we have as over s squared plus 1 plus bs over s squared plus 9, where a and b are constant. And then we can generate this equation is as squared plus 9as plus bs squared plus bs equal to s, because this one is equal to s. And from the similar terms, we can get a plus b is equal to 0 and 9a plus b is equal to 1. So we solve this equation, we got b is equal to 1 minus 9a, and we substitute b equal to 1 minus 9a into this equation here. We got a plus 1 minus 9a is equal to 0. So it's minus 8a is equal to minus 1, so a is equal to 1 over 8, and b should be equal to minus 1 over 8. And after the partial fraction, we have s over s squared plus 1 s squared plus 9 is equal to 1 over 8 s squared plus 1 minus 1 over 8 s squared plus 9. And finally, from the above, we substitute this into here, and we get the inverse Laplace of this. So finally, we have yt equal to 4 inverse Laplace of s over 8 s squared plus 1 minus 4 inverse Laplace of s over 8 s squared plus 9 plus 1/1 of cosine 3t minus 1/4 of sine 3t. And then we take the inverse of this. We got 4 over 8. Inverse of this is equal to cosine, right? Cosine t. And inverse of this is equal to 4 over 8. The inverse Laplace of this is equal to 1/1 of cosine 3t. So plus 1/1 of cosine 3t minus 1/1 of sine 3t. So this one is half cosine t, and this one is 1/6 cosine 3t plus 1/1 of cosine 3t minus 1/1 of sine 3t. And then these two terms is similar. So the final answer is yt is equal to half cosine t plus 1/6 of cosine 3t minus 1/1 of sine 3t. And that is what we got from the Laplace transform, the function of yt. So let me revise all the steps we have done. We are using Laplace transform to solve the second order differential equation, y dash plus 9y equal to 4 cosine t, y0 equal to 1 and y dash 0 equal to minus 1. We take the Laplace transform on both sides, we got this. And then we take the inverse Laplace transform on both sides, we have this. So if we want to solve this, the inverse Laplace transform of this, we have to do the partial fraction. After we have done the partial fraction, we got this. And after this, we finally substitute into the yt. We got the yt is equal to half cosine t plus 1/6 cosine 3t minus 1/1 sine 3t. And we have done it beautifully. So if you like this video, please subscribe and go to my channels and look for other mathematics and other tutorials as well. So thank you very much for your view. Adios, hasta la vista. So if you want to learn more from my YouTube channel, you can go to the YouTube homepage and type in Learn with Tom Lee. You can see my videos of Cantonese, my videos of Mandarinese, and also many tutorial videos in here. You can also get into my YouTube homepage and click on Playlists. There's Python programming learning, JavaScript, and simple algebra, and there is a lot of many other tutorial videos as well. So just subscribe to my channels and share the knowledge with me. You are very welcome to my channel. Thank you very much. Adios, hasta la vista.